Hello again. It might be a clickbaity sounding title, but dynamic structural cooling. Basically, you're an amateur astronomer and you need to cool your observatory building. And what's a clever way of doing that? So some might think of this as off topic, but if you happen to own a personal observatory in Southeast Florida in the hot months, yeah, when your dome is closed up, it gets hot in there. And how do you cool it down? You obviously don't want to put air conditioning in there because in Southeast Florida, that would be asking for condensation on your instruments and your optics. So no, you just want to move the extra hot air out and pull in, outside slightly cooler air. Drop the inside a good 10 degrees Fahrenheit or so. But you want it to be something that's inexpensive and doesn't require a lot of electronic mumbo jumbo. And you want it to be automated. So you don't want to have to go out there and turn it off and on all the time. You want it to be something that doesn't run on AC power, where you got to go, run power wiring or have a breaker put in by an electrician or pull a permit or any of that sort of stuff. You want it to be dynamic so that it runs an exhaust fan as needed, even if it's hot at night. So no solar panels. No, don't need no stinking smart electronics, no thermostats or, digital temperature sensors. And you don't want to have to require like a Raspberry Pi or a network connection or Wi-Fi or any of that stuff. You don't need a connection to the internet. You just make it where it runs. Now, I'm not going to be covering the specific of insulation, how you would actually insulate your attic or dome or whatever. You can get all sorts of insulation materials and vapor barriers and all that kinds of stuff. And depending upon where you're at, you might use different materials or different approaches, whether it's rain outside or snow outside, whether you have ice to deal with. So I'm going to be focusing on just moving the heated air and not going to be covering insulation materials or vapor barriers or that kind of thing. So the goal is hotter air out, less hot air in. So you need to have a source of air that's not as hot as what's already contained inside your closed space. And you need a way to get the outside air in and the inside air vented out. Make it where the interior, when it's closed up, is more tolerable for humans and astronomy equipment, so that your Maksutov Cassegrain secondary mirror doesn't melt off the front of your primary optics. So this is for any closed environment. If you have an observatory dome, then, before you start your observing, you're going to open up the dome and all the hot air is going to go out. This is for when things are still closed up and you want to make sure the inside temperature doesn't exceed a certain level. Now, if it does exceed that level, this is not going to help that. This is just to pull the temperature down so it doesn't exceed that level. So where does the air come from? The not as hot air. It comes in through something called a soffit vent. These are, if you look around the under edge of your roof, you'll see occasionally these vented covers. Those are called soffit vents. That's where the air comes in. On the back side of the vent, there's usually a screen to keep critters and stuff out. Since it has a screen and louvers on it, then, guys not knowing what they're doing, they're just painting your house. They're going to paint over your soffit, and then you got to go replace them or clean them out. Over time, insects are going to get stuck in the screen, so you got to clean those out or replace them. This is where you're going to pull your ambient cooler air in, and then you're going to push it out the top of your roof or vent. What I'm proposing here presumes that some of your soffits are working, some percentage of them are working to a certain degree. You may find that if you had your house built and then you had somebody come in and blow in insulation or put in batting insulation after your house was built, if they didn't pay attention, in other words, they weren't that great at attic roof insulation, they would just blow the insulation in right over your soffit vents or put the batting in right over your soffit vents, and therefore you have no circulation. So get out there with your shop vac, your garage vacuum, put it on blow, and just run it up against your soffit vents and have it, if it's blown insulation, this will blow it out. Unfortunately, if it's batting insulation, you have to go up in the attic, hopefully when it's cool, and cut it out so that the soffits are open, because there's not a lot of airflow velocity going on here. It's low speed. It's just meant to pull, over a long period of time, lots of cooler air in to displace the hotter air. How do you do this? Well, when my house was built in 1975, I had 2 turbines on the roof. Now, when the wind would blow, when the house was first built, they would spin, and I never noticed in the summertime that the house was getting hot. And then we had a hurricane. my roof didn't get pulled off, but some of the tiles did. And when I had them resurface the roof, they said, can't have the turbines anymore. We put in exhaust, basically tubes. And that will make it where the rain doesn't come in and where the hot air goes out. Great, but what's pulling the hot air out? Normal convection. That doesn't move it fast enough. In Florida heat, it'll build up heat in your attic or in your observatory dome, and it will just accumulate over time. And, with the heat index being these days 105, 108, something like that, Fahrenheit, you're going to have heat coming down from your attic inside your house and heat up your house. And then you got to run your air conditioning longer, and your power bill goes up during the hot summer months and all that kind of stuff. The turbines, hurricanes would come, and you need to take the top of the turbine off and then put a bag and then tape it. Otherwise, the turbine can be ripped off by the hurricane or by a tornado that comes out of the hurricane. Turbines were a great idea. And in warm places on the planet where there are no hurricanes, they're still a good idea. But the bearings aren't expensively precise. And over time, the turbine wobbles or sticks occasionally or gets bent. Somebody goes up on the roof and bumps it and bends it. And so it only moves during a high wind, or it stops moving at all. And then you don't have any air movement. Turbines, they were a good thing. They don't do as good anymore. So here's the substitution for the turbines. Non-moving things, passive air movement. So they put caps up there. So they just have a pipe or rectangular opening to the outside. And then to keep the rain out, they put a cap on it to let the air come out. Or if you have, let's say, a fancy kitchen with a blower hood, then this sort of J-neck thing with the screen on it, that's a blower exhaust. And that's how they blow the hot air out of your kitchen. But you need screens in there to keep the critters out, be it birds or lizards or squirrels or mice or rats, whatever. And you need them to be large enough that they move a lot of hot air through normal convection, absent fans, but not so large that the pressure from a Cat 5 hurricane coming through won't suck your roof off or collapse your end gables, or, bad stuff happens. They don't make them very large, and they only put a couple of them up on your roof, and they can be used for both septic sewer, sort of water plumbing things to let the bad gas out of your restrooms, or you can be used for venting your attic, those kind of things. So here's my conceptual solution. It's 2 fans. These are a particular kind of fans. They're not huge. They're chassis blower fans. These are used in computer racks. They can take high heat. They're brushless, so you don't have any brushes that will wear out over time. They're ball bearing, so they should last a long time. They have a screen guard on the inside, so if you happen to be up in the attic when these are running and your hand hits it, it's not going to wipe your fingers out or anything. If anything's crawling up in the attic, it's not going to suck it in and destroy it. It blows air out and up. So you put 2 of these on each side of an aluminum plate, and then you add 2 thermoelectric generators, TEGs. You can get these chips pretty cheaply, and they'll produce at most 12 volts out, and you have them power the motor. So as the attic heat builds up, the fans switch on, because the power that the fans run from is produced by the heat in the attic. So no heat, fans are off. Heat rises, fans come on. How long do the fans stay on? Until the temperature drops back down. It's not sun angle sensitive. So if your house heats up in the afternoon, then these can stay running into the evening after the sun's gone down and further remove hot air from the attic or from your dome or whatever. It's just a plate, 2 fans, 2 TEGs, and then you have some L brackets to mount it on the underside where there's a vent right above it that exhausts to the outside. I'm still in the process of getting parts in. I ordered enough parts to build this, and then the parts got delayed, and then they sent me the wrong part, and I get a new order on that part, and it's taking about a week longer than I thought it would. Otherwise, I just show it to you working. So the power source are TEG, thermoelectric power generators. Are these a proven science-y thing? Yes, they are. The deep space probes that use radioisotope thermoelectric generators. Thermoelectric generators. Yeah, they take the heat from radioisotopes of plutonium that are decaying, and they heat up thermocouples, and the thermocouples produce electricity, and that's what runs the spacecraft for many decades. These things, if they're not put to maximum heat, there's no reason they shouldn't last for a really long period of time. And the fans are ball bearing and brushless, so they're going to last for a long time as well. I doubt that your attic's going to get to 400 degrees Fahrenheit, so it won't be to the peak temperature of the TEG. There's no computers involved. It's just if they generate electricity, then it'll power the fan. And you wire them up in series so that you don't have like one of these chips producing 11 volts. You have 2 of the chips and you wire them in series. So If it's 11 volts, then it's actually producing 22 volts. And then you have a little device that will take the higher voltage and threshold it to 12 volts, which is the peak output of the fans. So it's self-governing. No computers needed. If it's hot, you get fans. If it's not hot, the fans shut off because there's no power source. You mount the fans on the aluminum plate. You mount the plate to the underside of wherever the roof is of your structure over an exhaust vent. So it pushes the air out the vent. It's better to push the air out the exhaust than it is to try and pull it in through the soffits and not push it out the exhaust. So that's why they're at the exhaust. The TEG chips mount one on each side, opposite the back side of the fan, so that the cold side of the TEG chip is cooled by the air blowing through the fan and out. TEGs work off of a temperature differential, and you need about 10 plus degrees Fahrenheit difference between the hot side hot and the cold side cold. It doesn't need to be refrigerated. It just needs to have a significant differential. Each one of the fans is 12 volts, 1 amp, 12 watts. So if you have the two fans running off of the two TEGs in series, that's 12 volts at 2 amps, 24 watts. So the thing that converts to 24 volts to 12 volts has to support roughly 20 watts. That's just how to spec it out. You don't need any Raspberry Pis or thermostats or digital converters. You don't need any of that stuff. You don't need a LAN connection to your home network or Wi-Fi or internet access. And the way you monitor it is, can you hear the fans? That's it. There's no lights. There's no indicators. If you hear the fans running away, must be hot. If you don't hear the fans, either something's wrong or the fans just don't need to be on right now. If it's really hot and you don't hear the fans, then you got a problem. So it's self-indicating. So in summary, problems like cooling have been around for a long time. And as technology improves, we maybe need to rethink whether what we already have are optimal or not, given new information. So if you're still using exhaust turbines and soffit vents and haven't thought about rainstorms and hurricanes and over time the blockage of your soffits, then rethink that. And a passive solution is okay, but if there's problems with a passive solution, then a dynamic solution involving, motorized fans, power sources, is going to be an improvement. The idea is we're not going to refrigerate this thing. We're going to cool it down enough where it's reasonable for use, be it your attic or your observatory dome. And it'll be closed loop, operating only as needed. Nothing complex in the way of closed loop circuitry controls and stuff. Definitely no AC voltage, no power wiring or circuit breakers to be installed. Probably no permit because it's all low voltage DC. There's no long wiring runs and it's self-powered and it's up out of the way in the attic. They might require you to put a power switch in it. That's easy enough to do. You can manually turn it off. It doesn't produce a huge amount of wind or torque, so you could probably unbolt it from the underside when it was running, but put a switch in it if you want. The idea is if the fans are running, you can exhaust more heated air than a passive solution just from soffits to exhaust plumbing. TEGs are modern technology. They're not large, they're not expensive, no fancy stuff involved. Unlike solar panels, photovoltaic cells or PVs, so long as the air is hot, the TEGs will run the fans, even at night. No batteries, no battery management system, no inverter to produce AC. Pretty straightforward. And then specs on buying the blower fan, the TEGs, the voltage converter, and even the L brackets for mounting it to the roof. And then, you need some miscellaneous parts and stuff. And if you're not a DIY kind of person, this is not an off-the-shelf commercial solution. Skills with tools and such is needed. If you're going to mount it in your own hot space, then you need to deal with the heat endurance. And if you have glass wool in your attic, any personal protection equipment for helping you out in that crawl space. Comments, question?
It sounds like a good idea. Good use for those little fans too.
Yeah, I've got the fans in. The fans actually came with AC power supplies, so I can test out to make sure the fans are working and such. I already had the aluminum plate. I've got lots of nuts and bolts that I can mount things with. I did have to get the what they call a voltage down converter that would convert maximum 24 volts down to 12 volts. I don't want to fry the fans if all of a sudden it gets really hot and both of the TEGs fire off at 12 volts and they get added in series and produce 24 volts going into a 12 volt fan. Probably wouldn't be good for the copper wiring in the fan coil. Originally, the fans were AC powered in computer racks.
Yeah.
And they found that they didn't need to have them AC powered, then they went to 12 volts DC, and then they wanted to reduce the size of the wiring. And so they went to 24 volts DC and then to 48 volts DC. And if you know about telephone switching centers, they have a lot of 48 volt DC available because that's what all the generators run off of.
Oh, yeah.
So they run at 48 volts DC, and they found out that they ran too fast, and essentially the brushed bearings would burn out too quick. So they created brushless motors, and now I think they're running them all the way down at 5 volts. So they're ball bearing brushless motors running at 5 volts, well less than an amp per motor. And given the improvements in fan blade design and voltage optimization and the brushless and ball bearings, I have no idea how long those things would last, but they're probably running on graphite for lubricant. So they're not going to need any oil anytime soon. But yeah, it's just me usually, as usual, connecting dots going, hey, I remember fans. Fans ran on power. How do I get power? The attic is hot. A dome is hot. I know a device that can convert heat into power. Okay, so if there's heat, there's power. If there's power, it runs the fans. And when it gets cooled down at night, the fans don't need to run anymore anyway. And I don't have to go in and turn it on. If the heat comes up in the daytime, at some point it'll get hot enough, turn the fans on and blow out the hot air. Closed loop. No computers needed. Anything else before I stop recording? Hearing nothing?